We are here in the conference of ANIDIS, and I have presented two works related to the application of SHM for damage identification in masonry structures. In particular, I have presented two different approaches, one using seismic interferometry for data-driven damage identification, so detection, but also localization and quantification of damage. And the other talk was about the use of surrogate model-based system identification also for damage identification. In this case, instead of using numerical finite element modeling, we use surrogate models which are computationally efficient for identification of certain model parameters that are damage sensitive. Okay, so this research belongs to an important research line of the group, which is the SHM of structures. In general, we usually use ambient vibration monitoring of structures. So we usually use a long-term monitoring and automated operational model analysis for the identification of structural pathologies. And we usually identify the damage, so the detection, through anomalies in the statistical distribution of modal features. But the problem is that variations in the natural frequencies are difficult to be related to variations in the stiffness of the structure. So here it's necessary to use the inverse calibration of any kind of model. The problem is that in structural heritage, the complexity of the geometry makes the numerical models very computationally intensive, so they are very difficult to be applied for continuous SHM. So the idea of these two presentations of this conference is two different ways of bypassing this computationally intensive finite element modeling with, on one hand, seismic interferometry, and on the other one, surrogate models. The benefits from both techniques are quite different. First, seismic interferometry is data-driven, so we don't need any kind of model. And the idea is to cross-correlate the measurements at different positions of the structure, so to measure the delays of the movements. So in this way, we are tracing the seismic waves traveling along the structure. And on the other one, surrogate model-based system identification relates certain parameters of the structure to the experimentally assessed modal features. So in this case, we can do a fitting of the different parameters of the structure continuously in time for continuous SHM identification.